Dear Mrs. Yon, first of all, I want to thank you that you accepted to accord us this interview. Please introduce yourself.
Rodica Ion, Professor of Nanomaterials and PhD Supervisors in Material Science at Valahia University, Târgoviște. Meanwhile, I am the head of the research center called Nanomaterials for Mechanical Systems, recognized at the same university from Târgoviște. At the same time, I am the leader of the nanomedicine team and president of Scientific Council at National Institute of Research and Development for Chemistry and Petrochemistry, Bucharest. I could say one of the most successful symbioses between teaching and research, taking into account that all my students could have access in the Institute's laboratory for experiments and discussion.
Please introduce your work and area of research in the most popular way possible.
As a new and exciting concept, the nanomaterials is now a challenge. With a size of 10 to minus 9 meters, nanomaterials are the base of a revolutionary science, being able to explain many unexplained properties or characteristics of materials and opening new application directions. We should mention here the new nanomaterials called fullerenes, called after the American architect Richard Buckminster Fuller, with the form of geodesic domes based on hexagons and pentagons, and who practically solve the special applications without any solution of AIDS, HIV, materials for intergalactic flights, so on. I introduced nanomaterials in medicine by applying them as oxygen singlet generators for tumor destructors. I am a chemist, and it was possible for me to couple chemistry with material science by synthesis, characterization, and applications.
What is so exciting about your research work?
The compounds that I synthesized, the area of application, the publications, all of them are exciting for my research work, especially for international recognition. It's not at all simple to be a scientist at any time. Request vocation, knowledge, love, and the will of iron in order to meet all the obligations of a scientist. You must entirely get a profession, to burn as a candle, to light and warm the imagination and aspirations.
Okay, what are the applications of your research?
The main question in this field is, what can nanomaterials do for us? Nanomaterials promise a revolution in many areas of life, from electronics to sensors and healthcare, industrial materials, food, security and transport. However, if we are to use nanomaterials in our macro world for interacting with them, we need interfaces. For many of these applications, it is necessary to connect with nanomaterials and understanding and to control the interface between nanomaterials and their environment. We need new tools and new insights. The engineering of surfaces and interfaces of nanostructures remains a central goal of modern solid-state physics and chemistry, since atomically controlled interfaces play a key role in the performance of nanodevices. Limitation in characterization tools have been a major obstacle to the development of controllable device interfaces. I created in Romania a school of porphyrins as nanomaterials with their synthesis, properties and applications, and also a school of photochemistry in the same time. I published the only book in 4 volumes of photochemistry for the first time in Romania. Generations of young students have studied porphyrins. There isn't any laboratory in Romania studying such compounds, porphyrins, flavocyanians, and their photochemistry. I received a lot of requests for porphyrins from Romania, first of all from Julius Hațeganu Medicine University, Romania, or Victor Babeș Institute, Valentina Hospital, Ștefan Longin Hospital from Bucharest, or Military Hospital from Bucharest, also from abroad for finalizing the PhD thesis. For example, Benoit Destasio, France, different requests from Grahamstown University, South Africa Republic. Also, I introduced porphyrins in photodynamic therapy, creating new sensitizers and methods for treating actinic keratosis as pre-malignant cancer.
How easy or challenging was the transition from a student in school and university to the researcher? And what is the status of the researches in your country?
For me, the transition from student to young researcher and then to senior researcher lasted 10 years. Time that I went through the gauntlet of theoretical research, technology, and then applied researches. I had the great chance to be supervised by a famous scientist specialized in hydroperoxide, extremely rare and short-lived compounds, studying how to produce them and their role in the photochemical conversion of solar energy with different sensitizers. From that time, the porphyrins marked my life because I started to use them as sensitizers. I felt that such nanocompounds are like a gold mine in different applications, especially in medicine, in photodynamic therapy of cancer, and also in environmental protection of cancer diagnosis.
Do you have your student dreams fulfilled?
For me, the transition from student to young researcher and then to senior researcher lasted 10 years. Time that I went through the gauntlet of theoretical research, technology, and then applied researches. I had the great chance to be supervised by a famous scientist specialized in hydroperoxide, extremely rare and short-lived compounds, studying how to produce them and their role in the photochemical conversion of solar energy with different sensitizers. From that time, the porphyrins marked my life because I started to use them as sensitizers. I felt that such nanocompounds are like a gold mine in different applications, especially in medicine, in photodynamic therapy of cancer, and also in environmental protection of cancer diagnosis.
What is most challenging in your profession?
The most challenging point in my profession is to find new materials, new methods of investigations, new applications. It is important to put chemistry to work for a better life, to put chemistry in the service of man, not to destroy him.
What about your international experience? Are there colleagues abroad that are interested in your research?
Certainly, my name and my papers can be found either cited or classified in different science databases as Scopus, Easy Web of Knowledge, Medscape, so on. I wrote many papers together with scientists from famous international laboratories and universities, very well quoted and recognized from other papers. Based on this, I submitted different international projects, some of them being successful.
Well, and now what about the compromises between your work and private life? How your friends and family react to your occupation and professional development?
My work day is usually of 20 hours. Is more, is less, I don't know. In science, we should think that for every paper we should spend couple of days to see the experiments, to correlate them, to repeat them, some of them. Otherwise, when we are invited to write some contributions for a book or to be a leader editor for some journals, for example, me, I have to spend many hours to read some papers, to correct them. All the time a scientist is between home and laboratory and between country and abroad. Someone said if you don't travel in science, you don't exist. It's true. Every year I participate at many conferences for project consortium or for different meetings, being national representing person in some European committees. Every year I travel around 10 times. For family, Saturday is dedicated all the time. Think that I am wife and mother, so I have some duties for my children or for my home. But I like what I'm doing and I can cover more or less all of them. Family is completely my support.
How is your research related to nanotechnologies?
As I already said, I studied the porphyrins as nanomaterials for cancer treatment. Skin cancer is the most common form of human cancer. It is estimated that over 1 million new cases occur annually. Photodynamic therapy involves the applications of photochemical reactions mediated by the interaction of a photosensitizing agent, light, and oxygen for the treatment of malignant non-benign diseases. Photodynamic therapy is a three-step procedure. In the first step, the photosensitizer is administered to the patient by one of several routes, for example, topical, oral, intravenous, being then taken up by the target cells. Secondly, there is an incubation period of minutes to days, and finally, the target tissue is exposed to the specific wavelength of light or laser, yielding to the tumor necrosis.
How you will address young people to pursue a scientific career?
Every year I have a special lecture of fourth class students, which is called Nanomaterials. I organize the lecture especially based on my results. I observe that all my students know very well my preoccupations, even after graduating, because they remember very well the experiments, the images, the solution offered by this area. They are using the knowledges from my lecture, my recommendation to their new jobs. I have many students working in different scientific laboratories. They are dedicating young people to their jobs and already recognized in the literature by their papers.
Are there international cooperation models or joint ventures in between countries?
These include multinational cooperation programs such as FP6 and FP7, as well as international organizations, INTAS, COST, and Eureka. The national framework and incentive for international science and technical collaboration are important for the key research organizations are pointed out. There are cooperation activities in international science and technology programs and bilateral science and technology agreements.
Are there persons, situations, or still events which encouraged your motivation to continue in this domain?
This is the most sensitive question. Yes, after my mom, who inspired in my career, encouraging me to follow medicine, was a very special scientist and teacher, Professor Danuta Fratkovia. As daughter of the famous Alexander Yablonsky, the discoverer of Yablonsky diagram, proper for primary photochemical processes, she really marked my career in science. I met her in Brussels in 1995, where I got a fellowship in photochemistry. After that, she invited me in his laboratory for many months in Poznan, Poland, where from I started to publish, to do experiments, putting together chemistry with my porphyrins, physics from his laboratory, and medical application in Poznan Clinical Hospital. My first publication with her raised up to now 170 citations, being one of the most important publications in this area. I am very proud for this. Unfortunately, she passed away in 2010, and I miss her very much in my career. I continue the cooperation with the other members from his laboratory, and now I have a good collaboration with Professor Danuta Vrubel from his laboratory, with a PhD agreement between Poznan University and Valahia University. The first students that I sent there, Simona Pope and Sergiu Sora, being now confirmed as doctors at Valahia University. So was a good start for me and for my career, and the list of international cooperation is much longer.
Well, based on your experience, would you say that it is harder for a woman to study and progress professionally in fields such as yours in relation to a man?
No, not at all. I had all the time in my career good collaborators men. I was head of men's teams and I made many collaborative works with men. I never observed any difference between women and men. By contrary, was an equilibrated team with innovative ideas.
Why do you believe that there are fewer women in the fields of sciences, technology, and mathematics?
First of all, because science in general is more difficult than other domains. You have to spend days and nights thinking at every experiment. Now the young people and young women are thinking to finish more quickly the experiments, to spend less time in the library or in the laboratory, to use many experiments from internet, so on. Maybe this could be one of the most cause.
What kind of abilities you think a person needs to study in the fields of sciences?
Imagination, tenacity, courage, optimism, desire to do well and to let something after you.
Okay, in your opinion, should there be overall campaigns targeting girls to encourage them to enter in the technical study programs?
Yes, for sure, because girls are more combative. I would say fighters. They know exactly where to go and ask answers. They show a special meticulosity.
What would you say is your most important achievement? Do you feel fulfilled and satisfied with your career?
My most important achievement is the cream based on nanoporphyrins for premalignant cancers. I had the contentment of mind that I put my achievement in science and serve those who need miraculous cure, cancer patients. Practically never can describe the tears from eyes of patient who left the hospital in good health. I remember very well some old patient whose doctor saved their eyes by applying my compounds. I offered to medical doctors only those compounds already homologated without any dangerous effects for humans, repeating the well-known European methods but with other compounds. This is a huge satisfaction. To save life with nanomaterials is a real challenge solved with such miraculous substances.
Are you fulfilled and happy with your career?
Yes, for sure. If I would start again, this would be the same career. I would follow the same way, no doubt. Think that I am between the best 1000 scientists from Romania and I have a Hirsch index of 11, which is a good one, more than 450 publications, many books in Romania and abroad at international recognized publishing house, Springer Verlag Bergen. I am proud of my results, but I cannot say that is the end. I am in a constant search for new materials, new solutions to scientific problems.
Well, thank you very much, Mrs. Ion, for this interview, and we will try to contact you further during our project. Have a nice day.